So people then have to like zoom in on, if they're using their phone, zoom in on it.
Geometry A, Unit 11A, some extra notes and examples. On page 19, you were asked to state the name of the figure and sketch what the cross-section is. So if you take a look at the examples here, you can see that each of the shapes have been named and the cross-sections have been shown. Remember, the general cylinder covers all of the shapes. Does not matter what the base shape is. It can have curved or straight edges. Whether or not that shape is one where the two bases are one on top of the other determines whether it's a right cylinder or an oblique one. If it's a right circular cylinder, we know that the base is a circle, or an oblique cylinder, we know that it's a circle as well. If we have prisms that we're talking about, our bases should be polygons. On page 20, number 3, there is an example that has you finding the lateral area and surface area of a prism that has a hexagon at the bottom. A regular hexagonal prism means that each of the sides are the same. I've drawn a quick shape for you where you can see each of the lateral sides are rectangles with dimensions of 8 by 6. If I take a look at the polygon on the bottom, which is a hexagon, I technically have 6 triangles, each of which have a 1/2 base times height for their area. And in this particular case, you can see that the height of the shape would be 3 radical 3 because each of those triangles is a 30, 60, 90 triangle. So in here, you can see this height right here was calculated by using this triangle, which is a 30, 60, 90 triangle. To do the lateral area, when I went through and did that, I found the area of each of the 6 rectangles, 6 by 8, and got 288. And then for the surface area, I went through and said, oh, well, that's the lateral area plus 2 bases of 54 radical 3, and I added those together. On page 21, number 2 at the top, we have Jenny building a cylinder out of cardboard, radius of 5, height of 10. How much cardboard does she need? To the nearest 10th. That is technically asking you to find the surface area, which I've gone through and done, substituting 5 in for the radius and 10 in for the height. Rounded to the nearest 10th, making sure that I show the whole decimal before I go through and round. For the additional question, additional practice question number 1 on page 21 also, we have the shape of something that sort of looks like a mailbox. And to do the total surface area, you can see I've kind of broken this down. In this particular case, I have 2 rectangles, which are the ones that are on the ends, so it's this one and the one that's over here, and those both have an area of 4 by 6. And then I have 2 rectangles. Let's suppose it's this one that's on the front here, and then the one behind it over here that has an area of 15 by 4 each. And then I have the bottom 15 by 6. And then in addition to that, I have 2 half circles that are here on the ends that I need to make sure that I add in. Each of those half circles has a radius of 3, and I know that because if this is a rectangle on the end here, and this dimension is 6, then so is the dimension at the top. So that's the diameter of the circle, and we're going to use the radius, which is 3. So I have 2 circles that are half circles, I should say. So it's 2 times 1/2 of pi r squared. Go through, get my answer, and end up with 258 plus 9 pi for my total area. So I just wanted to give you a couple of extra examples in case you needed to go back and take a look at anything.